Hello, my name is Juan Leon, and this is the video part for Lab 4 on Dr. Ozbay's Design of Aerospace Experiments course. So we gotta do part A, B, D, E, and F. Starting with part A, velocity contours, something. Okay, so going over the geometry, I don't wanna here. Not gonna go too much into it since we've done this for every other project. But pretty much I just aligned my figure with the origin right here. That way I could pretty much keep track of uh, where we're calculating the velocities at later on. The mesh, I was having some trouble generating a good mesh. We'll go over what I did real quick for this one. So I just did the test section instead of the whole wind tunnel. That made it a little easier for me. Then I just generated a triangle method and sized around the edge of the body here. I did 100 divisions, and that's pretty much it. Don't forget to have our name sections here, and that's pretty much it for the solutions. As usual, energy, so pretty much same settings as before, just K epsilon, enhanced wall treatment, pressure gradient effects. Materials, got air, boundary conditions, make sure all of these are walls, pressure outlet, velocity inlet, and then edit that velocity using the calibration for 40 hertz. That's what we get. And reference values, compute from the inlet. We're all set. I've already run this, so let's go ahead and get the values. Okay, so for the velocity, that's our velocity contour, the vectors, there it is. Okay, next thing we're asked is laminar boundary velocity at 3 different. Okay, so we're gonna have to create new surfaces for this. I'll show pretty much what I did. So since I put my bottom left corner at the origin, I just added the plate thickness here and with the corresponding probe height, just so we could compare this data more effectively. So these are the pore heights that we use in the experiment. So I just added the thickness of the plate to those and make sure to rake 8 points just so we have the same amount of data here. That's that. You do that for each location. 0.2 centimeters, 8 centimeters, 16. And we should be good. Once you get those, you just go to XY plot, select them, plotting along the Y here. And we're doing velocity. There it is. The first one, they're all gonna come out a little bit funky just because that pore height at 0.2 centimeters happens to be outside of the boundary layer. We explained that in our project. But there's that part. Next one, that was B. So now we gotta do D. Plot the variation wall shear stress, wall fluxes, wall shear stress, and we're gonna select the top here. There it is. Then skin friction. There it is. And finally, we get the drag force coefficient for the plate. So from here, we're only gonna get the drag force. then we're gonna non-dimensionalize it ourselves. So drag force, top, compute. Okay, there it is. So once we get that value, you're just gonna go ahead and put it into Excel. This value, then we just pretty much divide it by dynamic pressure and chord length, and we get the coefficient of drag. So here it is. That's what we did. Then you just do the Reynolds number and the coefficient of drag using the Blasius solutions, and that should be it.